Tanya Taylor coming to you today from the National Air and Space Museum here in Washington, D.C. Today we'll learn about the physics of flight, and as we explore the progression of airplanes today, we've noticed a trend in airplane wing design as it relates to the four forces of flight. Now I will turn it over to our own Ellie Hine to talk to you about our first observations.
The galleries today and looking at all the variety of aircraft, one thing that we noticed was the wing design. Not only bi-wing, single wing, tri-wing, but we noticed particularly the shape of the actual wing. In the 1900s, we're starting off with the Wright brothers design, and it really was kind of like a rectangle. In each of these wing designs, we're going to refer to the front of the wing as having the leading edge, and the back is the trailing edge. And you'll notice that the wing designs change over time. The Wright brothers had that rectangle. By the 1920s, the leading edge is 90 degrees out, but the trailing edge is now tapered. In the 1930s, it's an oval. Both the leading and trailing edges have been modified. And then in our present design, the leading edge is angled towards the fuselage and the trailing edge is at 90 degrees.
Thank you, Ellie, for that in-depth explanation. Now we'll turn to our expert on a friction force called lift. Let's go to Cassie Cusack. Hi, Cassie.
Leading edge travels over the wing. A difference in air velocity creates a difference in air pressure. With the higher pressure below the wing and lower pressure above the wing, the lower pressure creates lift as the wing moves upwards. Once the force provided by lift is great enough to overcome the weight of the airplane can ascend. So here's the plane by the Wright brothers, manufactured in 1920s. You see the box design, and now you're looking at a Fokker T2, manufactured in 1922. Wingspan is 24.3 meters, almost 5,000 kilograms. Here's the Lockheed 5B Vega, wingspan 12.5 meters, gross weight about 2,500 kilograms, manufactured in 1928. This is actually the plane flown by Amelia Earhart across the Atlantic and across the United States in 1932. Finally, you're looking at an Air Force and NASA test experimental plane built in the 1960s. You can see the different wingspan and design.
So far in our journey, we've talked about three of the forces of flight.
Lift, thrust.
Wait, what about drag? So what is drag? Drag is actually a form of friction, fluid friction. The fluid in this case is the air in our atmosphere. And the job of a designer is to reduce drag by streamlining the aircraft. For example, earlier in our journey, we were talking about wing design and wing shape and how it's oriented to the aircraft. The truth of the matter is, you don't want a big wing. You actually reduce drag by having a smaller surface area for your wing. It reduces the amount of drag. And a little known statistic, if you can reduce drag by 3%, you reduce the total amount of thrust needed by 49%. Drag has a huge impact on the efficiency of your aircraft. The ultimate goal of any aircraft designer is to balance those four forces in such a manner that a minimum amount of energy is required to allow the aircraft to fly with a maximum level of efficiency.